Hi, in this video we're going to do an example that's going to look familiar to you if you've been watching the other videos in the playlist. When we were talking about loans, I did a problem where there was an unknown number of payments example. And this example is going to look very similar to that. It's just a bond problem. My reason for showing you this very similar example is to again try to convince you that loans and bonds are the same thing, just from different perspectives. Okay, so let's look at the example. We've got a 2N year 1,000 face value bond with annual coupons, redeemable at par, is bought to yield 4% annual effective. The accumulation of discount in the nth year is $6.50. The book value immediately after the next to last coupon is $990.38, and we're asked to determine the price of the bond. Okay, in the loan problem I did like this, there were two solutions that I showed you, and I'm going to go through a similar process here and show you both of the solutions, both of the natural ways, what I consider to be two natural ways to attack this problem. The first way that I would do it is I look at the second sentence there, the accumulation of discount in the nth year. They're giving me the cap P sub n value. Now you've got to be a little bit careful. I mentioned this in the videos that if you're talking about a bond that's bought at a discount, I recognize that this bond is bought at a discount because it says the accumulation of discount. When you buy a bond at a discount, that column of P values, as we saw in the lesson video, the column of p-values is negative. And so the 6.50 is not the cap p-n value. The cap p sub n value is actually a negative 6.5. Okay, so I've got a negative 6.5 as my cap p sub n. Again, I know that because the bond was bought at a discount, so all these cap p values are negative. And I'm asked to determine the price of the bond. So I'm trying to, my thought process at this point is to relate the cap P column, the column of cap P values, to somehow the price of the bond. And I recognize that if I add up all of the cap P values, then I get the book value at time 0 minus the book value at time n, which is just the price minus the redemption value. So the price minus the redemption value is the sum of all the cap P values. And notice in this case, I've got annual coupons. It's a 2N year bond. There's actually 2N of those cap P values. And so the next slide here, I know what the redemption value is because I'm told in the problem that the bond is redeemable at par. Par is face value 1,000, so I'll just put in the 1,000 for cap R. And I also know that when I have these have level payments on an amortization table, which I do with these bonds, I have a level coupon amounts in this case. And so I know that when I sum up all of those cap P values, I can take the first cap P value and multiply that by an S angle, the number of coupons there are, which is 2N. So this is what I get. I've got this relationship now between the price of the bond and the cap P values. And actually what I'm going to do, let me clean up the slide a little bit by taking out that middle expression with the sigma notation, and I'm also going to add the 1,000 to the other side to see that the price of this bond then would be 1,000 plus cap P1 times an S angle 2N. Now, before I go on further, I just want to let's take a moment to talk about what's going to happen here. The cap P values we said were negative, and so that second term in that expression, 1,000 plus the cap P1 times an S angle 2N, the cap P1 times the S angle 2N is going to be a negative amount. So we're taking 1,000 plus this negative amount, which is going to be a number less than 1,000, which we should expect because the price should be less than 1,000, which is the redemption value, because again the bond is bought at a discount. Okay, so now let's proceed. How would we move on from here? I've got this one cap P value that was given to me, cap P sub n. It's a negative 6.5, and so I try to pluck out some other information from the problem to try to get another cap P value, and I can do that by looking at the next to last sentence, that the book value immediately after the next to last coupon, so that would be at time 2N minus 1, that book value is a 990.38. I also know the book value at time 2N is the redemption value. Remember, after the last coupon is paid, the book value there is whatever the redemption value is. It's 1,000 in this case, and what accounts for the difference between those two book values is, of course, the cap P sub 2n value. So cap P sub 2n would be the 990.38 minus 1,000. So cap P sub 2n is a negative 9.62. I'm expecting it to be negative, and it is. And so now, look, I've got the cap Pn value and I've got the cap P sub 2n value, and so I can relate those two. I know that the cap P column forms a geometric progression, so to get the cap P sub 2n value from the cap P sub n value, since there's n time periods between the two, I use this equation that cap P sub 2n would be cap P sub n times 1 plus I to the n. Plug in the numbers here, and solving, we'll get that the n value there is 10. So now I've actually got a value for n, 10. So the cap P sub n, the very first equation, cap P sub n equals a negative 6.5 is actually a cap P sub 10. And I'm seeking the value of cap P sub 1. That's what I really like, is the cap P sub 1 value. So I'll relate the cap P sub 10 value and the cap P sub 1 value. Again, knowing that that column of cap P's forms a geometric progression, cap P sub 10 would be cap P sub 1 times 1 plus I to the 9th. Plug in the numbers there and solve for cap P sub 1, and you'll get a negative 4.57. So at this point, I'm ready to get my answer. Go back and, the price then would be 1,000 plus this cap P sub 1 times an S angle 2n. N is 10, so I got an S angle 20 there. I've got what the annual effective interest rate is. It's 4%. That's what I bought the bond to yield. So, go through this, calculate this. I would calculate the cap piece, what's highlighted in red. I would just calculate that separately. Keep in mind that's going to be a negative number because the cap P sub 1 is a negative, and then add 1,000 to that, and you'll end up with 864 as the price then. So the price of this bond is $864. Okay, again, there's another natural way to attack this problem using book values, just using the book values, the cap B values. This is very simple, completely analogous to what we did with the loan example here. So let's look at this second, what I consider a natural way to solve the problem, and that is to start with the book values at time 2n minus 1 and at time 2n, knowing that these are those values, and I could actually relate these two in a different way to get what the coupon amount is. Remember, the relationship between neighboring book values is I could take the book value at time 2n and think of that as the book value at the time before that. That would be at time 2n minus 1, accumulate it by multiplying by 1 plus I, and then subtract off the entire coupon amount, the entire payment amount, in which this case is a cap C. Plug in your numbers here. I is again 4%. You got the cap B values, and you'll see that the coupon is going to be a 30 in this case. Now I'll pluck out the first information about the accumulation of discount in the nth year being 6.5. So the cap P sub n is a negative 6.5. That's going to allow me to find the amount of interest that I'm earning in the nth coupon payment, or the nth installment. That would be the coupon amount 30 minus the cap P sub n value. So I got 30 minus the cap P sub n value is a negative 6.5. So cap I sub n, the amount of interest that I'm earning in the nth installment, is 36.5. At this point, remember the other way to calculate the way we can also calculate the amount of interest at time n is based on what the book value is at time n minus 1. Take that book value at time n minus 1 and multiply it by the interest rate I. So in this case, I can solve for the book value at time n minus 1 by taking the cap I sub n value, 36.5, and dividing it by that 4% number, and I get that the book value at time n minus 1 is 912.50. So now look what I've got now. I've got a book value at time n minus 1 and a book value at time 2n minus 1, and there are n periods between those two time periods, and so I've also got that the coupons are 30 in between those time periods. So I've got everything I need. Remember, we think of the book value at time If I've got book values at different time periods, I take the earlier book value and I think of that as the present value, and the later book value and I think of that as the future value. And I've got the payments, there are 30 in between those periods, and there are in coupons or in years between time n minus 1 and 2n minus 1. And so I'd set up this equation. Again, I'm thinking of the 9, 12, 50. That's the book value time n minus 1. That's the present value. That's the earlier time value. That's the present value. And the 9, 90, 38 is the future value. The 30 is also the 30 is a payment. And so this is a compute in value, a compute in problem using your time value of money buttons on your calculator, and you'll get n equals 10, just like we did before. Once I got the n value of a 10, I know what the coupons are. I know what the redemption value is. I know how many there are now, how many coupons. There's actually 20 coupons because it's a 2N year bond with annual coupons. So it's 20 coupons of each of amount 30, and then plus the redemption value of 1,000. So just using the standard pricing formula here, the price of the bond will be a 30 times an A angle 20 at 4% plus the 1,000 times V to the 20th. That also at 4%, this standard pricing formula, and you get 864 just as before. Okay, so again, loans and bonds, they're exactly the same thing. We use the same principles, the same formulas, the same process to solve problems. And so that's why I wanted to show you this particular one. And also I wanted to show you this idea, this problem, because it had an accumulation of discount that was given, and I wanted to remind you or show you how to work with the cap p values when they're negative like this. Okay, so I will see you in the next video.